All right, rational root theorem. If you notice now, we're to a place where they're not giving us anything to start with. They're just telling us a polynomial, and they're going to ask us to solve it. So that's completely different. Up until this point, they gave us a factor to solve it with. They gave us a number to solve it with. Now they're not giving us anything. So we've got to give ourselves our own starting point. Well, rational root theorem gives us all possible rational zeros. Well, now you're saying, well, that's great, but what in the world's a rational zero? A rational number is anything that can be written as a fraction. So that includes like 2, or 1/3, or -5/12. Okay, so anything that is a rational number, if it is a solution, it will be listed in this set. Now understand, every number in this set is not a solution. All of them, or some of them could work, some of them could not, or none of them could work, okay? So here's how we find it. First of all, we start off with P. P is going to be all factors of the constant term. So anything that multiplies to give us 10. So I put a plus or minus out in front, and then anything that multiplies to give 10. Well, that is 10, 5, 2, and 1. Those are the things that multiply together to give us 10. 10 times 1, 5 times 2. Q, the leading coefficient, which in our case is 3. Anything that multiplies to give us 3. So 3 and 1. Now, individually, they tell us absolutely nothing. So what we have to look for is P over Q. P over Q is going to give us all possible rational zeros. So plus or minus, and then we're going to divide each one of these things. 10 over 3, leave it as a fraction. 10 over 1, well 10 divided by 1 is just 10, so I'm going to write down 10. 5 over 3, and then we have 5 over 1, which is 5. 2 over 3, 2 over 1, which is just 2. 1 over 3, and then 1 over 1, which is just 1. So that is a list of all possible rational zeros. If there is a number that will be a solution, it is listed in this set. There are 1, 2, 3, 4, 5, 6, 7, 8 times 2, because remember all these are positive and negative. So there's 16 possibilities right here. Okay? So if it asks you to find all possible rational zeros, that would be your solution, and you don't need to go any further. Now, let's say they ask you to solve it. Find all rational zeros and solve it. So the problem we're actually going to work on is number 5 in your packet. So 10x to the 4th plus 21x cubed, 10x squared, negative 3x, negative 2. Again, P over Q. P, all factors of the constant term. I want you to go ahead and do P over Q on your own. So pause the video, do P over Q. All right, our constant term is 2. So this is going to be plus or minus 2 and plus or minus 1. Q, all factors of 10. 10, 5, 2, 1. So P over Q is 2 over 10. That simplifies to 1 over 5. So I'm going to put 1 over 5. 2 over 5. 2 over 2, which is 1. And then 2 over 1, which is 2. Now let's try the 1. 1 over 10. 1 over 5. But we already have a 1 over 5. There's no reason to repeat that number. 1 over 2. And then 1 over 1, which is 1. So that is our entire set. You do not need to repeat the numbers, okay? So those are all of our possibilities. So what we have to do now is what I call the guessing game. We have to guess a number that is going to work. Well, how do we know that it works? Well, that means it's going to give us a remainder of 0, okay? So we're looking for a number that's going to give us a remainder of 0. And it is just guessing at this point. I'm going to try negative 1. So 10, negative 10, 11, negative 11, negative 1, 1, negative 2, 2, 0. Good. We guessed correctly. Now, you have an option right here. This is the polynomial 10x cubed plus 11x squared minus x minus 2. We can do factor by grouping, which works sometimes, or we can simply do p over q again. So, seems like a thing now. I'm just going to drop my phone in every video. You're going to use these numbers and put them here. So 10, 11, negative 1, negative 2. You use these same p over q's. So you use the same numbers to guess again. I'm going to try negative 1 again. You can try anything that you want to, but I think negative 1 might work for us. 10, negative 10, 1, negative 1, negative 2, positive 2, 0. It works. So far we have two solutions. We have negative 1 as a solution, and we have negative 1 as a solution. This is 10x squared plus x minus 2 equals 0. Guys, we're at a quadratic. You want to get down to the place that it's a quadratic. Once it's a quadratic, we can factor it, we can solve it. 10 times negative 2, negative 20, has to add to give a 1. Well, that is 5 and negative 4. So we get 10x plus 5, 10x minus 4, divide by 5 there, divide by 2 there. So we have 2x plus 1 and 5x minus 2 equals 0. Go ahead and solve those real quick for me, please. So after solving, you should get x equals negative 1/2, positive 2/5, negative 1, and negative 1. This was a degree 4 polynomial. There's all 4 of our solutions. I realize it was a long process, so I'm going to give you a couple of steps right here to kind of help you out. So when solving, the first thing is to do p over q. The second thing is to do your guessing game. And remember, we want a remainder of 0. And then if it's a quadratic, which means it's x squared, factor it. If not, guessing game again. All right, and you keep doing this process until you get it to a quadratic. Once it's a quadratic, factor it, solve it. The degree tells you the number of solutions. So x cubed has 3 solutions. X to the 4th is going to have 4 solutions, so on and so forth. All right, try your practice problems. Do as many of them that it's going to take you to make sure that you understand what's going on, and let me know if you have any questions.